Hello and welcome to Connect and Collaborate. I am Alex Hopkins, your on-air producer, and all week long we have had the chance to talk construction in Colorado. So before we get started, once again, to my audience out there, I'd like to ask you to please sign up for our newsletter at cobrt.com. Check out our events page while you're there, and also be sure to check out this podcast and more at cobrt.com/radio-podcast. But I'm going to go ahead and introduce my guest. I have with me Corey Biddle from Cardno. He is the Northwest Utility Engineering Manager at Cardno. How are you, Corey?
I am doing great.
Fantastic. Well, welcome. And I also have joining me by phone Andrew Sylvest. He is the Operations Manager for the Central Region Utilities of Surveying and Mapping LLC, better known as SAM Companies. How are you, Andrew?
I'm doing well, Alex. Thank you.
Yes, so thank you both for joining me. What I'm going to have you each do for me, and Andrew, I'm going to start here with you. If you'll just give me a little bit of your background and why you got started in engineering and how you ended up at SAM Companies.
I originally went to college for construction management, and I got into construction. And after working in construction, I decided to give the design world a shot. Getting into design and specifically subsurface utility engineering, I realized how much value there was in actually mapping utilities properly instead of destroying them during construction. I started my career with Cardno, worked with Corey for a while, and I joined SAM Companies about 9 months ago to take on a role to help support growth and development in their market for subsurface utility engineering and utility coordination.
Awesome. So do you mind taking just a minute to explain what subsurface utility engineering is for me?
Yeah, it's a standard that was written in 2002 by the American Society of Civil Engineers. It basically breaks utility data down into 4 quality levels. They're like grades in school: D to A. D is the worst and A is the best. And it's a process. It's a process that uses geophysics and engineering judgment as well as surveying to accurately or precisely map utilities tied back to the coordinates the design is in. So we actually have real utility data to design off of instead of just records or guesses.
Oh, cool. Okay. I'd imagine that technology has helped you guys with that over the years, for sure. So Corey.
Absolutely.
So Corey, do you mind giving us a background of you, how you got started, why engineering, and how you ended up and decided to ultimately stay with Cardno, even though Andrew left you there?
So I actually got into the field, well, originally I went to school for architecture.
Oh, okay.
But transitioned into the engineering and survey side and really fell in love with survey. Spent a lot of time in my early career just in the field as a party chief, working, construction staking, doing boundary surveys. Worked in Alaska for a while, just doing, aeronautical surveys way out in the middle of nowhere on the Yukon River. Is quite beautiful. I'm a bit of an outdoorsman. Spent a couple years down in Antarctica as well, surveying for the U.S. Antarctic program down there.
Do you like the cold? Is that?
No. I think 50 degrees is cold.
Oh, okay, good. All
so
right.
77 below,
Yeah.
That's even worse. But left there and got into the utility engineering side of things specifically. So worked with Cardno now to run the Northwest and developing our business up here.
Awesome.
Yeah.
So one of the reasons that we have you guys on is that you're both members of ACEC, which is the American Council of Engineering Companies of Colorado, which is a mouthful. But one of the things that ACEC works on is legislation for construction, right? Mm-hmm. So we had a bill that was recently signed by the governor. It's Senate Bill 18167, and it was concerning increased enforcement of requirements related to the location of underground facilities. This bill is also known as Colorado 811, One Call Bill. We already had one call law. Why the new law? Why the new law?
Well, it was actually semi-mandated. Back in 2016, U.S. Department of Transportation actually was looking at states' existing one-call laws and looking at just how adequate they were.
Okay.
When they looked at Colorado's one call law, they deemed it to be inadequate and suggested or encouraged new legislation be prepared to address more the enforceability side of it. And through the process of the drafting that new law, a lot of other things came up to make sure that the law covers just best practices and actually is a law that will help public health, safety, and welfare in the end.
Okay. And Andrew, did we really need this law?
Absolutely.
Okay.
Back in 2017, Senator Scott and Donovan had sponsored a bill. It was Senate Bill 17290 that was geared towards the depiction of underground utilities in engineering plans for construction. And at the same time, the Colorado Contractors Association was working on this bill, this Colorado 811 bill, for enforcement. And after reviewing the language in Senate Bill 290, the American Council of Engineering Companies, ACEC, Colorado, we decided that the language wasn't necessarily in line with national standards. And we met with Senator Scott and Donovan and Colorado Contractors Association, and Senate Bill 290 was tabled in 2017, and we worked in conjunction with each other to incorporate the ASCE standards into Senate Bill 167 for 2018. So it wasn't just enforcement at that time. The three pillars of the bill were better enforcement with a safety committee to handle the enforcement, the implementation of ASCE 38 during design for the subsurface utility engineering piece, and also the elimination of Tier 2 companies to where everyone became Tier 1 in Colorado. It would be a true one call, where when you called 811, you would get responses from all affected parties.
Okay, interesting. So let's talk about a little bit about this 2016 U.S. DOT Phmsa study.
Yes.
Yes. First of all, what does that stand for? I'm assuming it's an acronym.
Yeah, engineering is full of acronyms.
Yes.
What is it again, Andrew? The pipeline... I forget acronyms.
Pipeline Hazard Management
There you go.
Safety Association.
Yeah, there you go.
Okay. So yeah, let's talk a little bit about that study.
So some of the requirements that could have happened should we not have addressed the inadequacy. The fines, they were basically going to hold Colorado to federal standards until we addressed the problems. And those federal standards, actually the violations, the fees for those could have been astronomical relative to one call laws. Federal standards, it can be up to like 200, I think it's in the ballpark of like $205,000 for a violation, and up to like over $2 million for a series of violations.
Wow.
Where with the new legislation, I mean, the violations are, because that could like bankrupt any company out there.
Absolutely, and a lot of engineering firms, as we know, are definitely small business.
Yeah. And with legislation, you don't want to stop business. The idea of it is to like encourage safety, and so you have the violation like penalties for not complying. Yeah. But they shouldn't be such that it destroys the business. It's to encourage safe practices. So now the violation, I think it's $5,000 ish for the first violation, up to $75,000 for additional per year. So it's still a substantial, but you have to police it somehow.
Right. So I'm assuming that the national requirements then are much more strict.
Yes.
Okay. All right. That's
well, I shouldn't say much more strict. They're just geared more towards like pipeline specifically, where one call is for like all utilities, whether it's a pipeline, a telecommunication company, power, anything underground.
Okay. All right. Yeah. I appreciate that explanation there. And so how does this new bill accomplish the goals of reducing risk and saving us money? Andrew, or Corey, you look like you're ready to go. You were ready for that one. Go ahead, please.
Well, one element, especially what we're talking about here with like ACEC and everything, is incorporating that ASC 38 standard into the bill. Because using that ASC 38 standard, you're getting a much more accurate picture of what's down there. I mean, there's a lot of issues. Existing standard practice is just to, you know, you look for records about what's down there, and a lot of times the records don't exist. They're, you know, inadequate, they're inaccurate. To locate them somewhere in the real world, very hard to do. What else, Andrew? Anything to add?
Yeah, I guess the current practices in Colorado were not really in line with most states. Over 40 states have adopted the use of ASCE 38 through departments of transportation or municipalities. It's best practice from the Federal Highway Administration as well. And in Colorado, I guess it was more practice of collecting records, or people would put in one-call tickets and go survey the one-call marks. But one-call tickets, putting in an 811 dig request, that was always the intention, was damage prevention and basically establishing liability during construction. So if
construction is the key word there.
Absolutely. If the utility was damaged during an excavation and the mark from the one-call utility locator was within 2 feet of the damage, then it was the contractor had the liability for that damage. If the mark placed by the one-call locator was more than 2 feet away, the liability fell on the utility company. And engineers in Colorado, surveyors, owners for that matter, municipalities, they saw that as a free way to get utility data, and they started surveying one-call marks and using them for design. And that was never the intention of the law. The law was for the protection of the assets during construction and the liability of when there was a damage. So by adopting these standards, we're now using the work is being performed by licensed professional engineers and surveyors who use geophysics, who have training in utility construction, design, configuration, and using these geophysical methods to map these utilities, and then, as Corey said, survey them back using coordinates tied to the real world. So instead of having records or one-call marks or the use of potholing companies where they would go excavate in random places, you know, now you get a more complete picture, and it's a risk-based depiction. So when you depict the utilities, you say, you know, these are based on records, these are based on surface evidence, these are based on geophysics. So it's just bringing more information to the table in the design, and that's going to have better information that gets passed down all the way to the contractors, which is going to make the construction process faster, more efficient, and it's going to make it safer.
Yeah, it seems like an overall benefit for everyone. Yeah. How often was this happening? How often were things falling apart a little bit before this came into play?
It happens happens quite often. Not just in Colorado, all around the states. I mean, by not using the standard, when you go out there and just survey one-call marks and throw those on a plan, there's you still have issues with unknown utilities. Like I said, the records, the way they're marked out there. You get into issues with utility conflicts, which weren't identified during the design phase. And this is one of the ways of saving us money, because taxpayers ends up them paying for any of those, like utility. Like if you run into a utility down there, stops the project. What do you do with it? It has to be addressed. Yeah. You have to, and a lot of times it does require a design change, or just it pushes the schedule out. Anytime that happens, it's costing money, and the projects go over budget, and it happens constantly. And it happens, you know, to the tune of just millions of dollars. And who's paying for it? You know, we are as taxpayers.
To touch on that as well, when you have to have those design changes, they're emergencies. Or when you have to have relocations, they're emergency relocations. So utilities are getting designed and relocated in less than ideal situations because it becomes very time sensitive, and sometimes it's a safety issue. So if you do have to move the utility, you're not moving it well ahead of construction where it's very well planned out and designed. It's just an emergency and a fix in the field and a patch. So we're effectively putting a Band-Aid on it instead of, moving it somewhere where it will be sustainable and protected long term as well.
Yeah. So clearly this legislation was needed, right?
Oh, yeah.
We needed this to pass. What was your motivation to work together and visit all of these senators and try to get backing behind you?
It comes down to just best practice. I mean, it's almost like a professional obligation that you have to. It is the right way to do things. Doing a full subsurface utility investigation in the design phase. It is the most efficient way of addressing all these utility concerns. And we had a interest in seeing this bill pass, and we stayed involved with it from the get-go, so that any of the stakeholders out there, whether they be utility companies, other engineers and architects, contractors especially, any questions, concerns that they have, we're there to help answer those questions for them.
Yeah. So it's. Go ahead, please.
I would say that to echo that the National Cooperative Highway Research Program, which is a mixture of Federal Highway Administration and AASHTO, they came up with a synthesis in 2010 that mentioned that the ratepayer and the taxpayer are both the same person. So if a utility is damaged and the project owner has to pay for it, well, that's tax dollars. If the utility company has to pay for it, then that gets passed through Public Utility Commission to the people that are the ratepayer of the utility, which is the same person. In Colorado, the same people who pay utility bills are the same people who pay taxes. So I would say ACEC has a Stand as Stewards campaign where we're really pushing for the engineers to stand up and be stewards, and that's the responsible charge of an engineer, is to protect the health, safety, and welfare of the public. So if we can get motivated to help save life and also be better stewards of the state budget or the budget of the utility companies or the municipalities that we live in, it's our tax dollars that we're saving, and it's our fellow citizens that we're helping to protect.
Yeah, absolutely. And it seems common sense to me that we need this passed, right? Across the board. Yeah. Whether it's for the companies, for the taxpayers, across the board, it seems common sense. Did you guys face any backlash on trying to get this passed?
Yeah, we did.
Oh, that's surprising. Please explain.
Not a tremendous amount. I think it was more of a, I guess you could say, institutional opposition of this is kind of the way we've always done things. Mm-hmm. And I think Colorado was really trying to do things the right way. They were spending a good bit of money and effort into potholing utilities. They would try to put budget in there, but they were only getting data in certain places, and they were getting incomplete data. And I think they were really trying to do it the right way, but no one had really came and tried to educate and help. And it was just I would say the status quo was probably the biggest challenge. I don't think anyone was arguing of trying to save money, but maybe no one had tried to do it the right way, so they weren't aware there was a better way. And I think that was probably the biggest challenge we faced, was just a lack of knowledge or someone willing to give it a chance.
Okay. Mm-hmm. Any comments on that?
No, well said.
So I know that we're going to touch way more on this ASCE 38 standard. Do you mind explaining that, though, before we go to break here in about 5 minutes?
So it's basically the ASCE 38 standard, like Andrew said earlier, was created in 2002, and it is a standardized method for the depiction of subsurface utilities.
Okay.
And within that standard, the aim of it is to reduce the level of uncertainty, and to actually identify the level of certainty of a plotted utility. Standard practice on a set of plans, you just have a line drawn that says telephone, another line electric. Okay. Don't know where it came from, don't know how reliable it is. You just don't know. So the standard actually breaks it off into 3 different quality levels, D through A. I think Andrew touched on this earlier. But when you understand the certainty of it, you know, when you're making your design decisions, they're actually informed design decisions at that point.
Okay. So I want to walk through with you guys on your mission here, right? What senators did you see? Who did you get behind you on this? And because I'd imagine it was quite a bit of companies, right, and organizations around.
It was more us behind the senators. The senators were the drivers of it.
Okay.
Senators Ray Scott and Donovan, they were you know, instrumental in pushing this legislation through.
Yeah. So I am assuming that you're happy with the outcome. And what does this mean for the future of your companies right now?
Busy.
Would you like to speak to that, Andrew?
Yeah, I think we're preparing ourselves to play a bigger role in staffing up and supporting the growth of the industry in Colorado. We're also partnering with smaller firms and trying to promote the process as well. At SAM, we've been in talks with some firms in the Western Slope about providing education on how to provide these services. So we do have enough providers in the state to support the demand that's going to be there. And I think more importantly, with both Cardno and SAM, we care about the quality of the work. We have a lot of work to do. There's going to be a lot of companies moving into the state to provide this service that already do it elsewhere. And we also anticipate there being some companies local to Colorado that are going to start trying to provide this service and learning how to do it to help meet those needs. And I think the one thing that we care about, and it's the mission of UESI, which is the Utility Engineering and Surveying Institute, which is part of ASCE, is making sure that the providers of these services do it the right way and really give Colorado the quality of data that they deserve, and that we don't have companies that are cutting corners or maybe not using the right geophysics or don't have the right training doing these services where, you know, if CDOT has adopted this standard, they were going to adopt it ahead of time anyway. But if CDOT has a project and they let it out for bid, or not for bid, but for selection of a consultant, any consultant that does the job should be held to the same standard to do it the right way. I think that's what we're looking for, is to help grow that market and the service providers to make sure that we provide the quality of service that's required.
Yeah, so you guys have really gotten pretty big on this project, and you obviously got this Senate bill passed. That was in the last legislative session, right?
Right.
Okay. So we have 1 minute here. Anything else, any other shout-outs you'd like to give for getting this done, or anything you want to say to fellow people out there that maybe we're giving you a little pushback, like how good this is going to be for them?
I would like to thank Colorado Contractors Association. They were huge in this. ACEC, Colorado 811, Senators Scott and Donovan. It's just a lot of collaboration, and you know, a lot of people trying to do the right thing.
Yeah, absolutely. We are going to take a quick break here on Connect and Collaborate. Be sure to stay with us. We're going to have about a 5-minute commercial break. Okay. We'll be right back. In the meantime, be sure to like and subscribe our YouTube page. Check out this podcast and more at cobrt.com/radio-podcast. Hello, and welcome back to Connect and Collaborate. Once again, I'm Alex Hopkins, your on-air producer, and I have in studio with me Corey Biddle of Cardno, and Andrew Sylvest is joining us by phone from SAM Companies. Doing good? Feeling good after the break, guys?
Great.
Yes.
Yeah.
So we mentioned in the first half this ASCE a couple times, ASCE 38, and you mentioned that there's an A through D standards.
Quality levels.
Quality levels. Thank you. So do you mind going over what each of those stands for? I know A is the best and D is the worst, but what exactly does that mean?
What's behind the definitions?
Yes. Yes.
So quality D, which is basically your the lowest quality.
So like the grade D meat at Taco Bell that they use, right?
Exactly. That
okay.
way.
All right.
No, but it's that is information that is drawn on a map that is based on records information, essentially.
Okay.
And those records can be anything from like an as-built drawing to, you know, site foreman saying, I know there's a utility right there somewhere. You know, it's just record information of it, because ideally you're not going to be doing design work with just quality level D information, but it gives you an indication of what is out there, what is present on site. Oh. And then up from that is quality level C, and that's where you actually take your quality level D information, the records information, and reconcile it with your surface features, ones that you've actually surveyed in using traditional land surveying techniques. And like, so if you have a water valve out there or a fire hydrant, you know, you tie that location, and then you look at your quality level D information, and you can reconcile it and move it and adjust it as necessary in your professional judgment where that line is, but still, you know, quality level D information with just surface features. Still not a completely true, accurate picture of what, or it's not a very certain picture, I should say, of what's going on down there. Up from that is quality level B, and that is where the law, moving forward on certain projects that meet certain requirements, they'll have to make an attempt to achieve quality level B information in their subsurface utility investigation, unless there's a reasonable rationale by the professional engineer in responsible charge for not doing it. You know, I won't get into that right now.
Okay.
But quality level B information, that's where you actually use geophysical methods. You're actually tracing it out subsurface, and you can be using like a pipe and cable locator for that, you know, various types of GPR units, and list goes on and on. Acoustical GPR. Ground penetrating radar. And then there's also multi-channel ground penetrating radar.
Okay.
Time domain electromagnetic induction. Want to get
it only gets more detailed from here.
There's acoustical methods you can use as well.
Echolocation. Okay.
Essentially.
Yeah.
Can be used to find water lines and get a location of where those are. Just hopefully no big trucks go by.
Okay. Yeah.
Because you actually have microphones that you're using sometimes with those.
Oh.
Yeah.
I can imagine that would be pretty harrowing.
And then the highest quality level A, that's where you actually, it's an exposure of the utility. So your test holes or your potholes, we're actually digging down with vacuum excavation meets and exposing the utility and locating it into your survey coordinate system. So it's part of the design of exactly where that point is.
Okay. How accurate would you say from D to A, as far as knowing where some of these utilities are, right? Like a surveyorman saying, yeah, I'm pretty sure there's one here. How accurate are we when we get to A from that? He has like a 15-foot radius, 2 feet.
I like to say it's certainty. It's the certainty of the location.
Yes.
I mean, in any measurement out there, there's always inaccuracies.
Right.
Quantifying that accuracy is kind of hard to do.
Okay.
So some of the revisions to the ASE 38 standard, there will be certain accuracy standards possibly in there.
Okay.
But for now, it's just how you actually use the equipment. And there isn't necessarily an accuracy attributed to it.
Okay.
Per se, there is on your vertical location with with quality level A information, but with quality level B, it's just a certainty of location.
Okay. Awesome.
I would say, touching on that too, one common misconception that we get a lot is clients will call and ask us to do a quality level A investigation. I'm doing air quotes with my fingers, but you can't see me. And basically, the one thing we tell everyone is quality level D and C and B are lines. Quality level A is a point. So as Corey said, you've got a precise X, Y, and Z, northing, easting, and elevation tied to a test hole, which is quality level A, and that's to 500ths vertically, 500ths of a foot vertically. But that's only at that point. So one of the things that Asce in the revision Corey's referencing that's going to come out, they talk about a pothole is a failure in the pavement of a road. Where Asce is trying to get away from the term pothole and use a test hole because you're testing the accuracy of the geophysics, the quality level B investigation. Yeah. The big thing about subsurface utility engineering as a process is that when you have two test holes, you know exactly where those holes are. You have surveyed coordinates on the actual utility itself. But using the geophysics, you can use a quality level B line between the two. Whereas in the past, in Colorado, people would have a potholing contractor rather than a subsurface utility engineering consultant go out and dig two holes, but they actually had no idea where the utility was going between the holes. And, I've had cases before where someone had exposed the water line in two places and thought it went straight. And we actually found that it had 4 90-degree bends in between those two holes.
Oh, wow.
And it made no sense. No one knew why. And then after talking to the landowner, which would be our quality level D that Corey talked about, this guy said it's here. After talking to the landowner, we found out that when the water line was installed, there used to be power poles in the ground, and the electricity was overhead. And then when they put the power or the water, they ended up moving the power lines to underground 20 years later and removing the poles. So now that we look at it here in the future, we don't expect that water line to have 4 90-degree bends in it, but it did because it was installed in the 1970s when there were power poles instead of underground power. And that's really where subsurface utility engineering is an investigation and a process. And that's why you have to use all the geophysics, talk to people, gather records. It's really the reconciliation of all that data, like Corey talked about. You have to make sure that your records and your surface features and your geophysics and your test holes all come together to put the pieces of the puzzle together, so you have good data that's accurate for design.
Yeah, I would imagine you're cutting down on damage in the long run too, right?
Yeah, well, like the example that Andrew just mentioned, those 90-degree bends, if they don't show up on any record, and you start digging,
yeah,
you might think it's a straight line, and you go out there and there's actually a bend in the line, start digging, and bam, imagine that's a gas line.
Yeah.
Not good.
Right. Well, and I'm sure water does plenty of damage too. So is Colorado the only state that is now going to be performing utility investigations to this detail using the ASCE 38 standard as a basis?
No, it's Colorado's joining about 40 other states. So cool. We're pretty progressive as a state and pretty forward thinking with CDOT's Road X program and things where we're trying to be innovative. But this is one where it's been in practice for decades in other states. Virginia's been doing it probably longer than anyone else because of the Washington, D.C. area. Texas is probably one of the most advanced states at the use of subsurface utility engineering using ASCE 38. And they've seen drastic savings in time and cost on their projects by getting much higher quality depictions of utility data built into their plan sets during design.
All right. And what is the best practice and standard of care?
I would say, you want me to take that one? You want it?
I'll go for it. I'll pop in.
Okay. I think the best practice is treating it as a process. We've had some other states where people have asked for 32 SUs, and we try to explain to them SU is an acronym for subsurface utility engineering. No one calls and asks for 32 geotechnical engineerings, so maybe we've got a little bit of confusion here in what we're asking for. The best practice really would be to focus on your quality level D during like a feasibility study. So like Corey had referenced earlier, it's really just to get a rough idea of what's out there and who might be impacted. It's not really for design. It's more for feasibility. the best time to use quality level B as an investigation is concurrent with the topographic survey, which is normally 0 to 10% design when we're just getting started. That way, your quality level C surface features will be surveyed at the same time that you're designating with geophysics. And the designers are going to have a base map of underground utilities and a base map of topographic features to design off of. So now we've got something that's accurate above ground and below ground we can use to start our design. And then when you get to somewhere around 60% plans, when you start looking at drainage, that's the best time to look at quality level A test holes. And that's going to be done using your utility coordination process. So utility coordination is something that does happen in Colorado. Goodby and Associates has been doing utility coordination for a long time here. They were also instrumental in helping with this bill and partnering with all of us. And, you know, when they do a conflict matrix or a conflict analysis, that's when they say that, you know, okay, we see where this line is horizontally, but maybe we're going to have a conflict vertically. We need to go out and do a test hole and get some quality level A data there. So that's really the best flow, is to, you know, only expose the utility where it's absolutely necessary so we don't turn our roads into Swiss cheese.
Yeah. So I like that you're walking us through the phase of a project. And can you stress a little bit on the best return from that?
Well, it kind of goes back to the best practice also.
Okay.
And doing things right from the get-go, from the initial outset, even pre-design in that planning phase. The earlier you start it, the more informed your decisions are going to be moving forward. You might be spending a little bit of money that you previously wouldn't have prior to this method, but best practice does dictate that you'd make informed decisions that ultimately are going to save the project money. Okay. There's been multiple studies done, actually. There's a Purdue study done that actually showed basically for every dollar you spend in doing a subsurface utility investigation up front, essentially equates to a $4.61 savings in the long run of the project. And that's basically saying everything that we identified up front, all those utility conflicts, that had we not had done a SUE investigation and we encountered the problem down the road, it would have cost the project, you know, 4 times as much essentially.
Okay.
Than the cost of the SUE investigation up front.
Well, yeah, that's
so,
quite a bit.
Ultimately,
of
you're saving a lot of money for the project.
Yeah, absolutely. Now, I would argue here that if we don't run into any issues, I'm spending more up front. Am I not? Is that a wrong statement? I guess.
If you'd
gone through without ensuring this best practice, right? Which again, across the board is clearly common sense best idea. Could I make the argument though that if I don't do it but don't run into any issues?
Well, that's what these studies, that was the aim of these studies.
Okay.
Was to look at that.
Okay.
And there's been multiple studies, and every single one has shown, you might get this oddball project where you don't have any issues, but if you take 10 projects and take the average of the issues that could have happened had you not had done it.
Okay.
There's always a return. So it does come down to just having a SUE investigation done up front as just your best practice. That's what you have to do on every single job. Okay. You start doing on all your jobs, you see that return. Gotcha.
That's what I was trying to get at. Was out of 10, there's probably 9 that you were going to run into an issue anyway.
Exactly.
Right. Okay.
Alex, to touch on that story, Corey, the study that Corey mentioned from Purdue.
Yeah.
That study was done on $1 billion worth of transportation work, and there were 74 projects. 71 of the 74, they actually found savings. On 3 of the projects, there was a negative rate of return. They spent more money on subsurface utility engineering up front than they would have spent during design. So it's kind of like what you said. If they would have rolled the dice, they actually would have paid off there. There were no issues. But the $4.62 Corey's referencing is actually including negative rate of return on those 3 projects. Okay. So on the whole, the portfolio netted that return.
All right. So rolling the dice essentially is going to cost you more anyway.
Well, that's why
Yeah.
it comes down to it just being a best practice.
Yeah.
Just employ this process on.
Absolutely. So engineers have to sign and seal the utility investigation for
Yes.
certain public projects, right? How does this affect the liability of the engineer now?
So there is liability associated with it.
Yes.
Because you do have to now, a SUE investigation does need to have the seal of a professional engineer. But that's where you have your SUE consultants, that this is what they do.
Mm-hmm.
They are in charge of the entire process, from the records investigation to the geophysical investigation. That engineer has an understanding of it. So that's why hiring a qualified SUE consultant is so important, because you know that that professional engineer that's taking on the liability of that they have a complete understanding of it, not just saying, I'm going to hire this, somebody to go out there and not have any clue how they go about doing their work.
Okay.
The engineer at the company from the SUE firm will be in charge of the entire process, the entire investigation, including all the field work.
Okay. All right. So you have the SUE engineer and you have the engineer that's in charge of the project, and you guys coincide, right, on this. And so
The design engineer and then your SUE provider.
okay.
Yeah.
So the signing and the sealing comes from which engineer? Sorry.
So the engineer with the subsurface utility engineering firm,
Okay.
that's the one that's taking all the liability
Okay.
for all that information, or the liability that's associated with it.
So you're essentially
And that's why there's quality levels associated with it too.
right.
Because if you have showing something at quality level D, you're not supposed to be designing something like within a foot of a quality level D line.
Yeah.
I mean, that's just common sense.
Right.
And that's why those quality levels are there, to actually help mitigate that risk to the engineer that's actually stamping those drawings.
Okay. Thank you for that. So does it or will it increase design costs for a project?
Marginally, but that's where it comes down to those studies also. There might be a little bit of money more spent up front, but in the entire course of the project, you're basically just reallocating funds from construction and just moving a little bit of it up to the front end of the project to design,
Okay.
and actually saving the project money.
So at what point are people going, the companies that are building, when will they see their return?
What do you want to touch on that?
I would say they would probably see the returns in the first full construction cycle of projects that start design using ASCE 38. So it's normally about 2 to 3 years before you start seeing the return, because of projects that have already been designed now that are going to be let for bid and go to construction, they won't have this data built into the design plans. So the contractors aren't going to be able to realize that cost savings there. But as we have new projects that go into design, if they follow this process, the design is going to be risk-based, based on the quality of the utility data. And if we pass that information on to the contractors are going to be able to lower the contingency that they put in their bid, because there's less uncertainty in the utility data in a project that used subsurface utility engineering than one that did not. So Georgia and other states have done this, and what they found was, 3 to 5 years, really, they could start getting enough data to do a study. And I'd spoken with a gentleman who retired from the Federal Highway Administration. He was of their utilities group. And he said back in the early 2000s, he spoke with 10 different states from the Northeast, and they found that over a 10-year period, they thought they were averaging about $200 million annually in savings.
Wow.
So, but it took a while to get that going. So what happens is, if the project owners, such as CDOT or cities and counties, if they take this data and they pass it down to the contractors in the bid package, and we educate the contractors that if you see a design set of plans that has quality level B line work, you can trust that a lot more than you can quality level D. The contractors can carry less contingency because they have less risk, because they have more information. So they can work faster, they can work more efficiently, and it should lower the cost of construction and also lower the time required. Because if you're afraid, if you see the contractor's laying a pipe in the ground and they see that there's a fiber optic cable close to it, right now, the contractor is not going to plan on laying very much pipe a day because they have to be very leery of that line. But if we educate contractors and we say, you know, quality level D lines, you do need to be concerned with them. The quality level B lines, they should be within a few inches of where they're shown. Then a contractor can see that fiber optic line at quality level B and say, you know what, I can lay twice as much pipe a day as I used to. That's going to increase efficiency, that's going to decrease time, and that's going to lead to cost savings. And that's really where the values comes in. But it will take a full design cycle so contractors start bidding on jobs that have had this through the life of the project. So we're probably, I would say conservatively, we're looking to 5 years out, and we may start seeing things as fast as 2 years on smaller projects.
All right. So this is obviously very recently all been implemented, right, here in Colorado?
Yes.
Yes. So it's gonna take a while to see some results. Have you had any feedback yet on this from any other contractors, or have you seen any opinions from other companies?
Well, it's so new. It's still so new, and everybody's still trying to figure out even what it is, how it affects them. That's why, in conjunction with ACEC, there will be training series done throughout the state to actually start educating not just engineers and project owners, but contractors as well, because it's very important that every contractor out there understands what a SU drawing looks like and how to use that information that they're seeing. And it's the same thing with engineers too. When they're delivered a SU drawing, that they understand how to incorporate that data into their designs.
Okay. And how long do we have? Because with every regulatory bill, right, we have to give people some time to get those regulations in without being fined. Do we know how long that is before we have to implement those?
August 8th.
August 8th. Okay.
Yeah.
So it's right around the corner.
Yeah.
Yeah.
Months away.
Yeah. What would do you have an example of what kind of fines are going to happen? I know you mentioned 5,000, I believe, and then 75,000.
Well, hopefully there's no fines.
Correct. There's obviously goals, right? We have
exactly.
goals here. But is it the 5,000 for an infraction and then 75,000 after?
No, what is it, Andrew? Up to
it's
70?
Progressive.
Yeah.
Yes.
It's progressive, and it's also somewhat at the discretion of the safety committee. The intent is not to fine people. You know, this isn't a self-funding government bureaucracy. These are unpaid positions. These are people who honestly care about the health, safety, and welfare of the public. And the goal is, when we do have an offender, it's not going to be to fine those people. It's really education to try to explain to them what they did wrong and how they can do better. So, you know, no one wants to fine anyone. Taking money from people is really just a last resort to people who do not want to do things the right way and be safe.
There's nothing about the fines that is there to raise revenue. It is strictly there to encourage best practice.
Absolutely. Well, hopefully moving forward, we get everyone there by August 8th. Thank you so much, gentlemen, for joining me today. I really appreciate your time. And be sure to check out this podcast and more at cobrt.com/radio-podcast, and like and subscribe our YouTube page while you're here. Thank you again, Corey and Andrew.
You're welcome.